Hi everybody, so today we're going to talk about section 9.1, which really wraps up our discussion about linear equations and like graphing a single line and equations of single lines. Okay, so this really has two topics in it, and we're going to start with talking about horizontal and vertical lines. Okay, so you should have seen horizontal and vertical lines in your Algebra 1 class, so let me just remind you that if you have something like x equals a, where a is a number, we're going to have that this is a vertical line. Okay, and remember the slope of a vertical line is undefined. Okay, if we have something like y equals a when a is a number, you're going to get a horizontal line. Okay, and the slope of a horizontal line is 0. Okay, so let's do a couple of examples relating to horizontal and vertical lines. Okay, so we're going to write the equation of a vertical line through the point 4, -7. Okay, so we're going to remember that a vertical line has the equation x equals a. Okay, and then all we need to do is pick what number a makes sense. Okay, so because we have this point, the x value should be the same x value that you see in this point, right? If all the x values are the same, then it's got to be this x value. So we would write x equals 4, okay, and that's our equation of the line. All right, let's look at another example using horizontal and vertical lines. Okay, so we're looking at the line y equals -2. Okay, so it's important for us to remember that y equals a number is a horizontal line. Okay, so we're going to go to any point where y equals -2. This is a point where y equals -2. Okay, and then we're just going to draw our horizontal line. Okay, all right. So that's just a quick reminder of how to write the equation of those lines and then how to graph those lines. Okay, so let's move on to talking about our second topic, which is parallel and perpendicular. Okay. Again, you should have seen this in your Algebra 1 class, but let's review what this means, okay? So for parallel lines, okay, we know that they have the same slope. Okay. Perpendicular lines have opposite reciprocal slopes. Okay, and an example of what I mean by that is like 2/3. Okay, your first slope might be 2/3, and then your second slope would be opposite in sign and reciprocal. Okay, the opposite refers to the signs, positive and negative, and then reciprocal, of course, means the reciprocal of the fraction. Okay, so let's do an example using that. Okay, so we're asking the question, are the lines parallel, perpendicular, or neither? So let's look at our examples. Okay, so here's our two lines. Okay, our first line has the equation y equals 1/4 x minus 13. Our second line has the equation y equals 0.25x plus 1/13. Okay, now anytime we're asking a question about parallel or perpendicular, we're focused on the slope. Okay, so these are both in slope-intercept form, so I can just look at them and say what the slope is. So for the first one, my slope is 1/4. Okay, and for my second one, I can see that the slope is 0.25. Okay, now 1/4 and 0.25 are the same, right? So we would say that these lines are parallel, okay, and it's because they have the same slope. Both slope is 1/4 or 0.25. All right, let's look at another example. Okay, same question, are the lines parallel, perpendicular, or neither? Okay. So these two lines are not in slope-intercept form, okay? So we still want to find the slope of them because that's how we're going to answer this question, but you can see that these aren't in slope-intercept form. So the first thing I'm going to do is put the lines into slope-intercept form. Okay, for this one I just add 1 to both sides. Here I'm going to add x to both sides. Okay, and then I'm going to divide both sides by 2. Okay, and now I can read off the slope. So for this first line, my slope is 2, okay, which you could write as 2/1. Okay, my second slope is 1/2. Okay, so you can see these are reciprocals, okay, but they're not opposites, they're both positive. So we would say that these are neither. Okay, they have to be both opposites and reciprocals to be perpendicular. Okay, let's look at another example with that same question. Are they parallel or perpendicular or neither? Okay. Okay, so we have one line L1 that's going to pass through these 2 points, and the second line L2 is going to pass through these 2 points. Okay, so again, we want to find the slope. We're focused on the slope. Okay, but this time we need our slope formula. Remember, slope equals y2 minus y1 over x2 minus x1, right? Change in y over change in x. Okay, so we're going to do that for the first line. Okay, so my y2 was 12, my y1 was negative 3. Okay, my x2 was negative 2, my x1 was 1. Okay, so this is going to be 12 plus 3, which is 15, over negative 2 minus 1, which is negative 3. So I'll get negative 5. Okay, and then I'm going to do the same thing for my second line. Okay, so y2 minus y1, okay, over x2 minus x1. Okay, so negative 5 plus 2 is negative 3, okay, and then negative 10 minus 5 is negative 15. So this is going to give me 1/5. Okay, you can see that they're opposites, negative and positive, okay, and they're reciprocals, 5 over 1, 1 over 5. So these are perpendicular. Okay. All right. Last part to this question, still asking, are the lines parallel, perpendicular, or neither? Okay. All right. Now, x equals 2, remember from the very beginning of the video, this is a vertical line. Okay. Y equals 0 is a horizontal line. Okay. So we're going to draw a vertical line and a horizontal line. Okay. You can see visually that these are perpendicular. Okay. We don't need to show any other work. All vertical and horizontal lines are perpendicular to one another, so it's clear why we're concluding this. Okay, let's answer a slightly more advanced type of example. Okay. I think this is example 4. Yes. Okay, so we have this line 4x minus 7. Okay, and we're going to answer a couple of questions about this. Okay, so we're going to write an equation of a line that's parallel to L1 and goes through the point 0, 3. Okay, so the first thing I'm going to do is, because we're talking about parallel, I'm going to say what the slope of this line is. So here this is in slope-intercept form. My slope is 4. Okay, now because this says it's parallel to L1, okay, I know that the slope of this new line is also 4, right? Parallel, same slope. Okay, it says it goes through the point 0, 3. Okay, now this point is a special type of point because it has the form 0, comma, whatever. Okay, this 0 is what signals me that this is the y-intercept. Okay, if the first coordinate is 0, it's going to be on the y-axis. It is the y-intercept. Okay, so I have the slope and the y-intercept, so I'm going to use slope-intercept form. Okay, so I'm just going to fill in my information. Y is 4, or the slope is 4, and the y-coordinate of the y-intercept is 3. Okay. All right, now we're still going to use that same line L1, 4x minus 7. Okay, and now we're going to write an equation of the line perpendicular to L1 that goes through 4, 1. Okay, so now we're saying it's perpendicular. Okay, so that means the slope is going to be opposite reciprocal. Okay, so opposite, the previous slope was positive, this one is negative. Reciprocal, 4 goes to 1/4. Okay, so we have a slope, we have the point. Now, how do we know this isn't the y-intercept? You look at the first coordinate, it's 4, so this is not the y-intercept. Okay, it's just a random point on the line. So because of that, we have point, slope, we're going to use point slope form. Okay, and we're just going to fill in this information. So y minus 1 equals my slope. Okay, x minus x1. Okay, now just like we said in the previous section, you're free to leave this equation in any form, such as this one, unless the directions are specific about what form. Okay, so we can leave it like this. But if the directions were to say, put your answer in slope-intercept form, then we would need to simplify this to slope-intercept form. Okay? All right. I hope that reminds you guys of how to do some problems with parallel and perpendicular, and I will see you guys soon.